the task tracker is going to actually be available. So you have something called data node, I said. So the data node is going to store your data. There should be some component to process your data. So that is what you call it as a map reduce job. That map reduce job would be sliced into a number of smaller tasks. Those tasks would be running using your task tracker. So we will be seeing that in detail. For now, just understand that data node will also provide you a platform to store your data, that is your HDFS, and then it will provide you a platform to execute something on top of these data. That is what we call it as map or reduce task. Generically we call that as task. And we say something called data nodes are responsible for serving your read or write request from your file system client. So this is what, so this read or write request will come from your file system client. What are all your file system client? Okay, that is initially like for us to interact with your HDFS file system, that time we will also be your command line client. Otherwise most of the time the client would be nothing but your Java API or the MapReduce program that you will be using to actually talk to your actual system. There are a few things we'll have to understand. Whenever there is a request that is going to arise from those clients, so the request will be primarily given to someone that is closest to the reader. Let's understand that. So we will be getting a clear picture in the next session on MapReduce. For now, get started with this. If a cluster spans, your HDFS cluster can still be expanded into a number of places. The reason behind that is like it supports your multiple data centers across WAN configuration. So on startup, name node actually enters into a safe mode. As I said, like safe mode is some, as you can actually guess, safe mode is some initial stage where like essentially we need to actually cross check or verify things that everyone is running, and then only it needs to move into your name node. So that is one simple scenario you need to understand here. So once everything is all fine, your name node will automatically change from safe mode to normal mode. If something is quite a serious issue, then it cannot really switch over to your normal mode. That time manual intervention is required. Name node essentially replicates its blocks to other data nodes. So the whole important thing we need to get here is like name node essentially is a primary component that will trigger up the whole process. Data node, as we have said, it is a worker node that just does the work that is being assigned. So who's going to assign the work is what you call it as name node. Name node will enable you to provide you a way that will actually enable you to give you a number of techniques to process your actual file system metadata. Then it will actually update your metadata information and then takes care of the whole process of replicating your data block. So which means like your initial place where your data is all being sliced, and then your name node decides, okay, like I said, like at any point of time your HDFS blocks will have two more places, which means like when you say replication factor is 3, the data block, whatever data that you hold, right, the data would be available at two more places. So which means on the whole like you will have 3 data blocks. So what essentially happens here, like which means like who will be deciding about, okay, when there is a data node, the HDFS block coming in, what are all the different other data blocks that you have. So the decision would be made based on how we are going to actually in a more of a random solution. The decision would be made by your name node, but essentially that decision will be actually a random solution, because like when you say like you are actually replicating two things, the replication should not happen within the same machine, which means the backup concept itself gets failed. So the reason behind that is like you need to actually spread your data in a more random way in to be more distributed across your n number of machines. So that is what would enable your HDFS and its replication factor to add to the performance of your Hadoop also. Let's later on we will understand the whole process of understanding your HDFS to the replication factor to improve your performance later. For now we have seen HDFS to provide you a way to make your data fault tolerant and highly available. That is what we have seen. So just because of this replication factor, we also have another advantage called it is available for you to actually process your data in a more effective manner. So the reason behind that is this will add to your performance. The primary way of communication would happen through your TCP/IP protocol, that is your default internet protocol. Yes, HDFS is designed for large data sets. we need to understand that like your HDFS, as I have already said, the default block size for HDFS is 64 MB each chunk, whatever we have said, right? So each chunk should reside on a different data node. So which means like basically it will actually sit on a different data node. That too primarily when you talk about the actual replicated data node, for sure it should actually sit on different data nodes. Yes, finally we'll finish off with something called HDFS commands. HDFS commands provides you a way to actually connect to your server, that is your Hadoop server cluster, where you can actually connect to the cluster and then talk to your HDFS file system, because we have understood the concepts of HDFS, like how you will be actually understanding or how you will be working with your HDFS file system is what we call it as Hadoop space FS, and then the arguments comes into picture. This is something we need to understand here, because like there are few commands that you'll have to practice on top of your Hadoop system. So I'll be providing you the cloud server. Like for now, once we finish off this session, I'll demonstrate it on the next session's initial stages. Then I'll be providing you the cloud server, so which will provide you a way to enable things up, like you can actually give an ls. You can actually, like what essentially we'll have to do is, like for now initial stages, like we are going to interact with your HDFS file system. How do we do it is what we call it as Hadoop space fs hyphen ls slash. So which means like when you say Hadoop fs hyphen ls slash, whenever you are dealing with Hadoop space fs, which means it is going to be an operation on top of your Hadoop distributed file system. Make a note of that. So that is something very relevant. So once you do that, then you can actually give some specific operations, like okay, you want to list the files under slash, yes, give it. So you can still do a mkdir, you can actually create a directory under that. So that is also still possible. There are few commands that you will have to get started with. You can actually copy there are just 4 commands that you will be frequently using. So one is okay, listing out or understanding what are all the files inside that. So the other one is like copying or moving the files between your Linux file system into your HDFS file system and vice versa. So which means like this is quite relevant, because like HDFS would be the primary place where you will be having all your data taken as input, and HDFS will always be the primary place where your output of your MapReduce job would also be produced over there. So which means for Hadoop, the default file system, when you say like it is going to deal with files, so this is what the default file system is. We need to understand that very much clearly. Got it? So that is what we call it as HDFS, and these are all few commands that will provide you a way to enable things up. So for now,
So what would be the limit on the number of blocks that we can give? So is there a limit?
sorry, please come again.
What would be the limit on the number of blocks?
Okay,
So I
that
mean,
is
if it is the file is 1 gigabyte and the default is 64 MB,
okay.
the number of blocks would be 16, right?
Yeah.
So I mean, how many blocks, maximum blocks can we have? Like 1,000, 10,000? Is there a limit?
So like it's quite straightforward. You yourself know the answer. Essentially, it all depends upon the input size. So the output, the number of blocks is not controlled by us, right? We just say whatever be the input you give, this would be the block size. So which means that is nothing but whatever be the input divided by your block size, which gives you the number of blocks that you'll have to process.
So there is no limit, right?
That should not be
I
any
can have
limit. That is the
1,000
reason
blocks
why
or
we call this
10,000
as
blocks.
a big data processing solution, right? So when we say like this is only for 5 GB, then this 5 GB itself is not at all an essential thing. We are talking in terms of petabytes and terabytes. So there is no such limit virtually.
Thank you.
Yeah.